Thank you. Dear colleagues, we are glad to welcome you to the Scholar Horizontal Meeting for Technical Sciences. My name is Hanna Kostevia. I am today's moderator. Scholars from different parts of the world are present today. Our first speakers, Sergey Robotko and Andrei Topalov, with a presentation on the topic IoT for industrial and marine complexes, are invited to talk. Mr. Sergey Robotko, Andrei Topalov.
Yeah. Give me a few seconds, please. I will share my screen. So can you see that one? Yeah, thank you. So I'm the PhD student of Mykolaiv Shipbuilding University, and this is the IoT for industrial and marine complexes. So the Internet of Things now is the powerful part of the industrialization during the last decades. Each year we are looking at positive progress of IoT that give us unlimited, almost unlimited actually, possibilities at improving the industrial sector. At this slide you can see the evolution of the wireless networking. And if you talk about the latest one, so together with internet, we can see the progress of the hardware, like Wi-Fi 7. This is the latest one, which gives us about up to 30 gigabits per second and allow us to almost totally refuse the wireless. Fourth industrial revolution harnesses the power of IoT. Advanced analytics and automation that revolutionize industrial and marine complexes. It enables a real-time data exchange, predictive maintenance, and efficient resource management, leading the enhanced productivity, cost reduction, and improved safety. So at this slide, you can see the top 10 cloud providers, and let's talk about them closer because I have the experience with about the 7 of this one. So for the IoT, for the industrial ones, the best are AWS, but with this huge amount of services, they are most expensive from there. The Azure from Microsoft, this is a good one, but the price models is not so clear because the simple VPS is started from $50 per one. If compared with DigitalOcean clouds, where you can just buy some droplet for $5 per once, this is actually expensive. So the Azure and Google Cloud, they are good both. And Google Cloud has a lot of different APIs, the good AI, so you can use it, and the price is good, much more better than AWS. The Alibaba Cloud, not at the recommendation list because this is like the China government cloud, so we will not recommend that one. The Salesforce, the same as DigitalOcean, they are a good one, they are cheap, they can use everybody, and yeah, this is a good one too. The Dell and IBM, actually, this is more industrial clouds. So, for example, because they use the United States government, so at the next slides, you can see the IoT controllers that compatible with these clouds. So DigitalOcean is, as I said, the cheap, the good, but if compare, for example, with the AWS, they have only about 10% of functionality of the AWS. So this is for some cheap services, so not for all. The next one is the Adobe. Adobe is good for some recognition, but not for some other. And as I know, the Adobe, they allocated their services at the AWS, so it looks like the same as AWS. The Dropbox is only for the file sharing, the file savings, and for using it for example, to save some video streams or some company or service files. So at this slide, you can see the technical objects of industrial IoT systems, like the industrial robots, boilers, chemical reactors, steam turbines, the ladders, and internal combustion engines. So this is the examples where you can use it. And if you talk about the good example from the latest years, the good ones is the BMW that are creating, for example, just the cars with the all cars contain the heat seats, and for using them you have just to pay the subscriptions. So you pay subscription, you have some heat seated, but each car they contain that hardware. So this is the interesting approach, and I think in the future it will be the popular model. So here's the example of the modern offers of the industrial IoTs. This is the controller that can work with Microsoft Azure, with IBM. So it have the web interface, the data logging, and it work with a lot of data acquisition system that can be compatible with a lot of systems. So this is the scheme of this microsystem, and the next slides you can see the examples of the using IoT. So here is the example how to use it with the gas turbine engines, the scheme. How these engines work with some sensors, how it's sending to the Ethernet to internet, to clouds, etc. And on this slide, you can see the hardware that can be working with gas turbine engines. On the next one is the HMI of embedded monitoring and automatic connection system for gas turbine engines. HMI is a human management interface. So it's just like the user interface for your gas turbine. So the next example is the specialized pyrolysis complex based on IoT that works on the different hardware too. So you can see the real photo of this system and the another visualization of the real implemented IoT and this complex. This picture, the controllers that was used in this complex. And another good example is the floating docks based on IoT, where you can implement the wireless system, wireless technologies to this one to control and take the data acquisition system, create the data acquisition system of different temperature sensors, pressure sensors to manage the different valves, engines, etc. This is what the hardware using on this floating dock system and wireless technologies based on different GSM, the GPRS, 3G system and technologies. So this is the HMI of this floating docks system that you can see, and there was created the experimental stand for these floating docks based on IoT for experimenting and using this system. So on this slide, you can see a computerized intelligence system for remote diagnostic of the level sensors of floating docks, ballast complexes. So the next is the modern control theory and IoT. The one of the most important particularities of the development second please. Emacs is that they can implement intelligent principles and technologies of automatic control based on the artificial neural networks, the fuzzy system, the hybrid narrow fuzzy system, evolutionary algorithm, and and another algorithms. So, and click the button. So as the conclusion, in conclusion, we have explored the potential of the IoT in the development of embedded monitoring and automatic control system for complex industrial processes, showcasing its application in specialized pyrolysis complexes and floating docks. These examples demonstrate the power of IoT in enhancing functionality structures, software, hardware, and multi-level HMIs for optimizing process control. And thank you for your attention. And any question to me?
Yes, please. I have a question for you. Could you please tell a little bit more about application of Internet of Things to gas turbines? Maybe you have researched something about this.
Let me click to this. About the implementation. So that was the investigation about that, but give me a few seconds. It's not clicking to backward. Gas turbine. To this graph. So you mean the implementation of the IoT, how it works? You mean, or can you?
I mean, like what parameters it controls or something? What is function and application to gas turbine?
Yeah, so actually I'm not diving deeply to managing this system, but it's collecting the
Data, maybe.
information from different sensors. The pressure, like you can see in the image, the pressure sensor, temperature sensors, and it can manage using this information, using the all controllers. And pre-programmed programs, you can manage the output signals to this turbine to manage this system. So I can tell you the more information about how specifically manage and what parameters.
Thank you for your answer. I saw the information on the slides.
Mm-hmm.
Okay. Yeah. I just asked it about it because you will understand. Can I do my presentation right now, or with the schedule? I think. Oh, sorry, maybe more questions.
Yeah. Okay. Yeah. Thank you for your question.
Thank you. The next speaker is Badri Dizamadze with the topic increasing.
It's Diasamidze, okay.
Sorry. So with the topic increasing the efficiency of combustion chambers of gas turbine engines.
Thank you.
Mr.
Wait a minute, please.
Sorry.
Creating my. So the topic of my presentation is researching of increasing the efficiency of combustion chambers of gas turbine engines. As previous speaker said, I can dive deeply into this topic at some point. I'm not aware too much about Internet of Things, but combustion is my passion. It would be quite briefly today. general plan about my presentation. Please take a look at it. And firstly, I will count my general field of study. Then we'll take steps to the aim of my whole research. Recently, I have completed my PhD thesis and defended it. So I'm now a full PhD, and I want to thank you to giving your attention today. So let's start. The general field of study is mechanical engineering at some point and environmental engineering. This is very actual theme of research for my, I think so, because pollution and energy conversion are very important topics today. Mechanical engineering is a discipline that applies to engineering physics, mathematics, materials, applied mathematics, principles of to design, analyze, manufacture, and maintain mechanical systems. It is one of the oldest and broadest of engineering disciplines. Mechanical engineers, as I consider myself, use principles such as heat, force, energy, and mass conversion to analyze the static and dynamic physical systems. The research deals with the law of heat transfer in fluid flow dynamics in combustion chambers of gas turbine unit. Environmental engineering, on its part, deals with the efforts to prevent and control air, water, soil, and noise pollution. To generalize, I think I want to say that gas turbines, steam turbines application are very broadened into power plants, marine applications. So they provide us with electricity and heat, which is very important to humanity. And the main aim of my research is to analyze the possibility of developing modern low-emission dual-fuel combustion chambers for gas turbine units of both naval and offshore energetics that meets environmental requirements, increase efficiency of combustion process, and decrease emission level of air pollutant in dual-fuel low-emission combustion chambers. Why I have chosen dual-fuel? Because it is advanced research of my colleagues and very promising application of simultaneous liquid and gasoil fuel. And current trends in development of gas turbine engines are accompanied by significant increase in thermal and dynamic loads on the elements of their structures, including the elements of combustion chambers. In our opinion, research in this area will be relevant, and we will be able to significantly increase the efficiency of dual fuel chambers workflow and to extend the limits of flame spread in volume of combustion chambers. One of the promising methods of increasing stability of combustion process is the intensification of the combustion of hydrocarbons using low temperature plasma. This will be discussed further. Analysis of recent research and publications shows that despite the large amount of scientific research in the field of low-emission combustion chambers, the methodological and technical aspects of solving the problem of creating dual-fuel combustion chambers have not been sufficiently developed up to date. Large number of studies of dual-fuel combustion chambers have been done mainly by experimental methods, and I am aimed to do the theoretical and experimental research. The project is based on working hypotheses about the possibility of complex physical and chemical influence of low temperature air plasma on the process of turbulent combustion, heterogeneous fuels which can be effectively used to organize the workflow of dual fuel combustion gas turbine. The techniques and idea that have been used by me. Basic methods, a general research methodology, method of comparison, method of mathematical modeling, and method of physical modeling. To increase the efficiency of combustion process, it is proposed to use the idea of preliminary mixing of liquid and gaseous fuel with air and axial radial swirls. Fine dispersion of liquid fuels with high-speed airflow after the high-pressure compressor, as well as activation of lean air fuel mixture with temperature-low plasma jets, which will ensure the transition from one type of fuel to another without stopping the gas turbine engine, and will low producing of toxic emission components. Wait a minute. Today we will dive deeply in the mathematical modeling, but I want you to ensure that it has been made by me, And, to describe not so deeply, I will tell that it considers transferring heat from one state to another, also droplet, liquid behavior, and kinetic energy of turbulence, dissipation rate of turbulence energy, etc., etc., etc. As you may know, the mathematics is all the assumption, and the real physics sometimes prove mathematic models, sometimes don't. So the verification of modeling of my research have been made as experimentally and with analyzing the experiments of other authors. And it shows that my theoretical experiment was quite adequate. Here you can see the comparison method is used to compare effectiveness of the method of fuel supply. And further in my research, I will upgrade this. This is development of model of plasma activation of fuel combustion and mechanism of fuel oxidation in the combustion chamber. Specific components and reactions have been studied, and this could. Here we can see the liquid fuel droplet tracks and the changes in diameter and different modes of fuel supply. So by analyzing these theoretical experiments, I have done my conclusions that some of them are great, some of them not so great, and by this I have done some experimental researches also. This is photo of plasma chemical element. It aided my combustion. Here you can see plasma torch, and this is graphics of plasma energy characteristics. With a plasma 8, fuel burns in better way, and also the pollutant or like CO from chemical tablet, it reduces. Here you can see mass concentrations for different methods, mass concentration of nitrogen oxide and carbon oxide outlet of the outlet section in the heat pipe from different methods of fuel supply. Here is upgraded version with plasma assisted combustion. So for different modes of supply, we have seen significant decrease of pollutant. As ideas for future research, I could see our future research could be aimed to obtain more accurate methods of developing three-dimensional mathematical modeling, which includes modification and improvement of fixes, topological mesh turbulence, mathematical models, and achieves the results. On the other hand, much of our information comes from the theoretical math modeling, so it would be reasonable to prove it with experiment and to compare it with worldwide data. As conclusion, I can say that research of proposed topic significantly expands the understanding of physical chemical mechanism of plasma activation and combustion process of gaseous and liquid fuels. This allows for the first time in the world to develop the theoretical foundation of the method of increasing the efficiency of dual fuel gas turbine combustion chamber due to plasma support. On this basis, it could be developed projects of the newest generation of Ukraine gas turbine engines working on both liquid and gaseous fuel and providing both indicators of efficiency and toxicity of exhaust gases. Thank you for your attention. If there are any questions, I could answer them.
Thank you. Have you got any question for Mr. Badri? No? Okay.
Maybe
And now,
I have a little question. Badri, say maybe you have back ideas for future research. Maybe open this slide.
Oh, thanks. Wait a minute, please.
It's 19.
Mm-hmm.
And you write about conclusion, and I'm interested what you think about this, what you do next step for this subject. For me, very interesting.
Okay, I will tell by myself, if you may me, okay? Because my ideas for my future research, they are not all mine, you know, because world information. I have strong scientific director, and we consider research in such topics like hydrogen combustion in gas turbines, also ammonia combustion. It could provide carbon oxide downfall significantly. This is what comes to my mind at first place. And also hydrogen combustion is very promising topic in European Union, as I know. And by the way, ammonia combustion is now have been made in Japan, but not been made in Europe. And so this would be great topic.
Many thanks for answer.
Thank you.
thanks. And now, let's continue our work in the section rooms. The first room, technical and technology. The second room, IT. The rooms will be open until 2045. 1 second, please.
So, dear participants, now you will choose for yourself this Zoom room, and communicate in this Zoom room with your colleagues. So you will tell directions of your investigations and maybe some project articles you would like to discuss. So present yourself in these rooms.
If you say simple, it is what you want, and any questions for your colleagues.
Yes, for some cooperation. So please, you can add one room and after that change it for another room. And we will stop our Facebook broadcasting.